Hope you enjoyed the first part of JSpring. Let me introduce you to my co-speaker for today. Well, not really. I developed this talk together with Benjamin. Benjamin is a PMC member for Apache Shiro and for Apache Maven, just like myself. But he couldn't be here today. So I'm doing the talk on my own. You'll have to stick with me, but I hope I will not disappoint you. So we talked about performance during the opening keynote, right? And this was all about application performance. And in a way, today, in this next 45 minutes, we're going to discuss performance as well, but not of your application, but the process that builds your application, aka your build. And well, from studies we know that the majority of the Java ecosystem still uses Maven. I'm very happy with that because I'm, as I said, contributing to Maven myself as well. So let's dive into how we can actually work to improve our Maven builds. Can I see a raise of hands, please? Who has ever played a sword fight while waiting for a Maven build? Wow, that's actually more. Keep them raised, please. How many of you considered doing this, but were like, my manager will probably fire me for this? Okay, a few more, a few more. How many of you know this comic, by the way? Okay, and who of you is like, no matter what that guy is saying, I'm not gonna raise my hand? Okay, that's very honest of you, thank you, sir. Well, of course, playing a sword fight is one way to deal with a slow Maven build. And it's definitely fun in a way. Alternatively, you can just go for yet another coffee break until you have like 20 cups of coffee a day and you're still boosted with energy but got nothing done. Another thing that you could do, and that I highly encourage, is trying to actually work on improving your Maven builds. And I'm not saying this because, oh yeah, it's fun to optimize the shit out of it. There's actually evidence from research by Gradle, and who would have thought that I would be mentioning Gradle today, that says, and I quote, "We haven't seen any company yet where investing into a more efficient build was not leading to a significant return on investment. Successful teams have an efficient build infrastructure." And we all know this, right? I mean, fast feedback, that's what we want to have. We want unit tests that are blazing fast so that we know immediately when we screw up. And the same applies to our whole build process, because that's not only about running tests, that's also about producing the build artifacts, building Docker containers and whatnot. So, how do we actually achieve this? Well, actually, the process isn't that complicated. We start at the top, and we start by measuring our build. And if I say measuring the build, I do not mean looking at this last line of output that says build completed 5 seconds, because yes, that is measuring, and in a way it tells you how long your build runs, but it doesn't give you that much insight, does it really? It tells you you wasted yet another 20 minutes of your life waiting for a build. But what you want to know is, why did it take 20 minutes? So we need a more detailed analysis. That brings us to the second phase, where we can actually try to pinpoint, why is my build so slow? What is consuming the time? And only if we know that, we can start working on improvements. It doesn't make sense to start with improving without knowing what actually your bottleneck is, just like Leonard said in the opening keynote. If you don't know what your bottleneck is, first find that and then start improving. And that's why I have this shirt saying it works on my machine, because all the things I'm going to show you today, they work on a particular project. They work in that context, and I will tell you why that solution solves that particular problem. So take this as inspiration, take it as a toolbox so that you know the knobs that you can twist and turn, but don't blindly copy and paste a fix or something that you think will fix your build into your project. And with that out of the way, I think it is time to start with the first thing that we need to do in our process, which is actually measuring why our build takes so long. And as I said, we need more detailed information for that than just the 20-minute build output at the end. And for that, I'm going to show you an extension to Maven, which is called the OpenTelemetry extension. You probably know OpenTelemetry already because you use it to collect metrics from your running application. And you can collect time spans and see how long an API call takes and why it takes 5 seconds. Oh, wait, 4 seconds out of that is for querying a database or for invoking another API. Well, you can use OpenTelemetry for your builds as well. And we do this by adding an extension to our Maven build. Extensions are a bit like plugins. You probably know plugins, right? You add that to your pom.xml and then it enhances your build with new features. And extensions are plugins but on steroids. They allow you to hook deeper into the build process, give you access to core Maven components, let you even amend those components with new behaviors. And one of the things that this extension does is it registers on every relevant event in the build lifecycle that happens and emits spans into OpenTelemetry, which you can then later collect using a collector. So how do we actually use it? Well, the first thing is that we create an extensions.xml in the root folder /.mvn of our project. And we describe there that we want to use the OpenTelemetry Maven extension. Don't be fooled, by the way, by the version number, because it might read alpha, but I don't know, they never released a beta or even a non-alpha beta thing. But they are on 146 nevertheless. I don't know why they keep on tagging it alpha, but as far as I've seen, it works pretty well. And then we need to have an OpenTelemetry collector. Maybe you already have one in your organization and you can just use that one. But if you do not, there's a Docker image called Jaeger All-in-One that I'll also be using during the demo today, which has the collector and the user interface so that you can actually query and visualize your spans. And when you have done all that, you're ready to go. Now, this is quite a bit of work, and maybe you don't need such detailed analysis. I've written a blog that gives you a few simpler alternatives. I'm not going to highlight them all here today, but I will share my slides afterwards. If you follow me on social media, you can see the link, and you can also click on that link and see, hey, maybe there's a simpler approach than this. Once you've done that, you don't want to run OpenTelemetry with every build that you run, so you need to pass an argument to your Maven build, which is OTel traces exporter is OLTP. Only if you do that, it will activate the extension. It will actually start collecting spans and traces and send them to Jaeger. The default value, by the way, is none, and if you don't specify it, you will hence not activate the extension, which is great. If you have done all this, you can open telemetry, you can open Jaeger, I have to say, and by default it looks a bit like this. Now I'm going to show you how that actually works in practice. I will be using the Shiro project. As I said, Benjamin is a core contributor to that, so we will use a part of their build, not the whole project, because that will simply mean that I need more time than I have today. So I'll be building a part of their project with the OpenTelemetry extension, and we will see how Jaeger actually works in finding a bottleneck. So I'm running demo 1 for this. I've already opened Jaeger, so that's great. And I'm copying the extensions file and running Maven here. Okay, that's great. Starts building 15 modules. And as soon as it starts, I can already say find traces. As you see, there's a Maven service. By the way, is it also readable for the people in the back, or should I make it a little bit larger? I see a few people nodding and thumbs up, so that's great, thank you. I click on Find Traces, and I can see that my Maven Shiro build is running already. And it gives quite some information. Let me see, is it done yet? It's not done yet, but it's running a few tests still. And, well, if we open it, we can already see kind of where the bottleneck is, right? I don't think it really takes a scientist to see what what is slowing down our build in this case, right? You can give a shout. Core module, indeed. Core module is definitely, oh, it's done, that's great. Let me refresh once more. So the core module is definitely taking the most time out of that, what do we have, 1 minute here. So it makes sense to dive into the core module and see what in the core module is taking so much time. I'll just open it. And then once again, I don't think this is a very hard one. We can see that Surefire is by far taking the most time. So looking at this, it doesn't make sense to start throwing all kinds of improvements into our build unless we fix this bottleneck first. Our tests are slowing us down. Agreed all? Makes sense, right? So we should look at improving our test speed. Well, of course, you could do micro-analysis on each and every test that you have in your test suite, but let me double check how many tests did they have here. 307. I don't really feel like micro-optimizing 307 unit tests, but maybe there's something else that we can do. And the first thing that I would like to try here is see if I can actually run those tests in parallel. Because by default, Surefire runs your tests in sequence. You probably knew that. Maybe you did not. Now you do. It runs all your tests in sequence, 307 unit test classes. That's going to take a little while. So what can we do to improve our test run time? We can tell Surefire to run those tests in parallel. That's great. It works only, I have to add that, it only works for the tests within one module. So we have a multi-module project build here, as I said, and this will only run the tests within one module in parallel. It makes sense to apply this when you see that you have many idle cores, when you run your build. Well, I didn't show you, but you have to trust me on my blue eyes on this one. My machine wasn't working that hard to run that build. Only one CPU core was. If you have tests that wait for I/O, it could also make sense to apply this technique. Great. What will it do? It will run your tests using multiple threads, and it will use the number of CPU cores. I believe it will do -1, but I'm not 100% sure of this. But it will make kind of a sane guess how many threads it would make sense to spin up. And also, if you have tests that run for a very long time, it could also make sense to do this, because then the one test that runs for a long time will not prevent other shorter running tests from running in parallel. A few caveats to take into account here. First of all, and this is an important one, your tests have to be parallelizable. What does that mean? Maybe you are using some singleton variables from your production scope. Maybe they aren't guarded for synchronization and multi-threading. I hope they are, but well, maybe it is not necessary in your context and you never invested time to do that. I could think of a few use cases for that, so let's assume it's valid. But that means that those tests, if you run them in parallel, they might fail, because another test is also accessing the same variable and making assumptions about its states. There's two things you can do. You can say, okay, well, then for this module, no parallel tests, I'm sorry. Or you can say, I'm going to fix the test to make it thread safe. Or you can tell JUnit, execute in the same thread. But that only works if you use JUnit. It does not work for other frameworks. The second caveat to make here is that, as strange as it may sound, it may bottleneck your overall build. Because if your CPU is working on all the tests in one particular module, it will not build other modules, which we will discuss later today, at the same time, because all your threads are still busy. So how do we do it? Well, there's two ways we can do this. We can do this through Surefire or through JUnit. Let's run over them. If we use Surefire, we can use the parallel parameter, which accepts 5 values for what can we run in parallel. Either nothing, only the methods within a class, the classes and the methods in parallel, or just everything. And obviously, they're sorted in terms of how much parallelism will you achieve. You specify that using a command line parameter. You define a Maven property parallel, let's say classes and methods, or you can add it in your pom.xml. This works great if you are on JUnit 4, or if you use another testing framework like TestNG or Spock. It's maintained by the Maven core team because it's part of Surefire, but on the other hand, it requires all tests to be thread safe. If you have a few tests that are not thread safe, you're out of luck. The configuration, especially in such situations, can be a bit verbose because you might have to repeat for every module whether or not to run in parallel. And this might be the biggest caveat here, it doesn't work on Jupyter. And that is, as we know, the latest version of the JUnit ecosystem. It could be a bit disappointing to see that, well, this parameter that is documented in Surefire does not work for JUnit Jupyter. But fear not, JUnit Jupyter has its own parallelization mechanism, so you can also use this. And they offer free ways to configure it. The JUnit platform properties file, a system parameter that is specified when you launch the Surefire, the JUnit JVM, or you can use Java annotations. The JUnit platform property files lets you specify as first the fact that you actually want to use parallelism, because by default it's turned off. Then you can say, okay, I want to run all the tests in a class concurrently, but all the classes in sequence. This will already speed up a little bit. And you can go even further and say, I want also to run multiple classes in parallel. And you can combine the two of them. By the way, their documentation has a really nice visualization of all the possible combinations that you can make out of these latter two configuration options. Alternatively, as I said, you can pass them as JVM arguments to the JVM that gets spun up by Surefire. And this is a neat thing, you can actually define it per test class. Using a JUnit specific annotation, you can say, well, this class is suitable for concurrent running, while another class maybe is not. Well, why would you consider this option? First of all, it allows you for a finer granularity in terms of what can be run in parallel and what cannot. Secondly, you can also say, hey, this test should run in sequence, but others should run in parallel, which is not possible if you use Surefire. It's part of Jupyter, so if you are already using JUnit Jupyter, it comes out of the box, you already have it. And this is also a great thing, IDEs actually, most IDEs understand this and will happily do the same thing for you. So also if you run your tests not through Maven, but for instance through IntelliJ, it will also work. On the other hand, if you do not use JUnit Jupyter, well, obviously it will not work because it's part of their platform. If you use TestNG or Spock, for instance, they might have different options that do the same thing, but this approach is not going to work for you. And it's a bit more work to control this from the command line if you would choose to do so. Let's see a demo out of this. And I'm going back here. I'm going to say the parallel test demo. What I first need to do, because the Shiro codebase has a few tests that do not work in parallel yet, so I patched a few tests to actually disable parallel execution there, and then I'm going to run Maven. By the way, if you feel like playing around with these demos, at the end I'll have a link to a GitHub repo that has all these demos, so you can actually try them yourself on your own machine, so maybe they also work on your machine and not only on mine. In the meantime, let us have a quick look at Jaeger. This was our first build, and it took a little under 1 minute, as we can see here, 75 seconds. Oh. It was fast. See, from 75 to 31. And I did not cheat because we ran until the core module, right? I mean, we ran all the tests, only some failed. I did not cheat here. I did not skip a module. We ran the same number of modules, the same number of tests, and only at the end of running the test, it appears that some fail. We can dive into that, but I'm not going to do that because that's not what this talk is about. Thing is, and that's the lesson to take with you, some tests may be flaky here as well. That also in itself is already a cause for investigation, but as I said, I'm not going to do that investigation today. It's a bit of a shame that I have this t-shirt because it doesn't even work on my machine. But obviously, if we look again at the detailed trace, we can see, well, still a majority of the work is being done in core, but the difference with the other modules is already getting smaller. So our build is more equally spreading its time over the various modules, right? That's what this shows us. Let's see. This was one example which I had at hand in case the demo would feel even worse than it just did. We see, this is not on my machine, but on Benjamin's machine, and you see it goes down from 1.5 minutes to 50 seconds, which is more or less the same reduction in time, right? Okay, now that we have optimized one module, and we see that most modules take a roughly equal amount of time, it's time to look at the next improvement that we can make, which is, hey, we built all these modules in sequence. And we could see that when we go here. We see that we only built this module after that one, etc., etc., etc. What if we could actually run a few modules in parallel? And I don't know, has any of you used Maven parallel builds before? What is the biggest disadvantage of parallel builds, in your opinion? Say again? Flaky tests is one, that's for sure. My personal frustration is the fact that the log is completely useless because all those modules that are being built in parallel are all throwing their output to my terminal, and it's up to me to figure out which log line belongs to which module and what phase in that module. Well, I've got news for you. Maven Daemon is out for quite some time already, and it fixes, among other things, this issue. The Maven Daemon is a process that you can use to speed up your build significantly by using a daemon process. So a daemon process, a thing that runs in the background, and that just waits for us to actually start interacting with it. How does the Maven Daemon help? Well, it does that in a few ways. The first, and I think one of the bigger improvements, is it spins up a JVM just once. If you've been playing with GraalVM, you know that a native executable spins up in like microseconds, milliseconds maybe, but the JVM usually takes quite a few seconds to start up. Then the code needs to be JITted, so it becomes hot and it eventually gets optimized for your CPU, and all this takes time. And then after 1 minute, all that work is thrown out of the window because the JVM is shut down. And then you start your new build and the whole process repeats itself. Maven Daemon, on the other hand, says, well, we have this JVM, we have this just-in-time optimizations. Let's keep them. Let's run that JVM continuously and only put it to work when you need it to work. It keeps the JVM warm. It also keeps your plugin definitions warm because once your plugins are loaded into memory, they will stay there until you run Maven the next time. And then all those plugins are already loaded. As I said, it also runs your build in parallel, which is a great addition as compared to using the capital T switch in Maven itself. Because this time, it will not clutter your output. It will collect all the output for each module, and only when the whole build is done, it will emit that to the console in a structured way. So you can actually make sense out of it again and say, okay, well, that line belongs to this phase of that module. Oh, now I understand. And then finally, as I said, Maven already has parallel builds, but it has a relatively simple algorithm to determine what could be run in parallel. Maven Daemon uses the Smart Builder extension by Takari to actually improve on that parallelism even further and make even smarter optimizations in terms of which module can I run together with which other module. Of course, there can be dependencies between modules in your build. It all takes care of that, but it tries to feed your CPU using as much modules in parallel as it can. When does it make sense to use this? Well, first of all, if you have a large project, and by large I do not mean your enterprise project with 20 modules, I mean projects like Quarkus, which has close to 1,000 modules. Obviously, in enterprise projects it also makes sense, but the larger the better, because all those pom.xml files get read at the start of your build, only to be discarded after a few minutes. Imagine the advantage you have if you do that only once and then keep them into memory. It also helps if you have many plugins. As I said, they're kept in memory, they're kept warm, so that also optimizes quite a bit. And if you have heavy plugins, it becomes also interesting. Heavy plugins like, for instance, the Kotlin compiler, the Scala compiler, that will just take a few seconds to actually load all that stuff into memory and only then to start working. As before, we have a few caveats here. The first thing is you need to use only plugins that are multi-threaded, that are suitable for multi-threaded usage. The plugins that ship with Maven, so all the plugins by the Maven team, are multi-threaded. That's all fine, but some older plugins and also some third-party plugins, as well as some old versions of Maven plugins, may not be thread safe. If you use them, you're on your own, but you're probably going to see build failures nevertheless. What can you do? Of course, make sure you're on the latest version of your plugin. Then, of course, you could say, well, okay, I'm going to say -T1. That's one way to put it, but then we're throwing out all the optimizations out of the window again, so that doesn't make sense. Or actually address the root cause, ask the plugin maintainer, hey, can you please make it suitable for multi-threaded execution? Second caveat to be aware of is that the Maven daemon re-implements a few parts of Maven, especially around parsing the maven.config file. And there are a few known bugs in that. You may not even be affected by it, but just be aware of it. Some parts of Maven are re-implemented and may behave different than what you're used to. Okay, then how do you do it? Well, first of all, you need to install the Maven daemon, which comes as a command line executable. It's a native executable compiled with GraalVM and such, so you need to take care that you download the distribution for your operating system and your machine architecture. And then the second job you have is retraining your finger gymnastics, because rather than MVN, you need to type MVND. That's going to be a difficult one, I know. I can totally relate. Some people say, well, why don't you create an alias? Well, maybe at some point you try to investigate why it does not work with MVND and it does work with MVN. And then if you have created an alias, you can't run MVN anymore. So I would say do not make an alias. And you can learn yourself a few new tricks. You can use mvnd-status to see if there's actually a daemon running, which JVM does it use, etc. You can use mvnd build time is true, so it will give you a relatively simple output with timings and small suggestions where you may find bottlenecks in your build. Or you can say smart builder profiling is true. You'll get a very extensive timing report with detailed bottleneck analysis. I'm not going to show these, but know that they are available in the Maven daemon. And it might even mean that you don't need OpenTelemetry from that point on. Let's see how that works. daemon. So what are we doing? I'm going to make sure that the previous build gets cleaned up before, otherwise it would really be cheating. Now I'm first going to do the regular build, the one that took roughly a minute, I believe. That gives me the time to take a sip of water, which I typically forget when I'm on stage, so it's good to have this little break here.
I can ask a question. What's your experience with the Maven daemon on pipeline agents?
Interesting question. What's my experience with Maven daemon in build pipelines? It could make sense, but typically builds are run in a containerized environment, and that means that the container is disposed of after your build's done. And there goes the optimization of keeping the JVM warm. So you could do it, and for instance, you will still gain in terms of building modules in parallel and all those other things, but you will not have the gain of having a warm JVM. Okay, let's see what have we done so far. I ran yet another build. This was the build with, I think I still have parallel tests enabled, so let's see how that goes. We saw it took 36 seconds. Now I'm going to run it with Maven daemon. We see the output is different. We see it will utilize 9 threads maximum because my machine has 10 CPU cores and it will keep 1 available for running Slack and Teams. We can see that it is on 16 seconds and 93% already, so that goes pretty quick. And we have only 1 module, which is 0 core and still fails because indeed I forgot to disable the parallel unit tests. Should have done that up front, I'm sorry for that. I thought it would be in Jaeger as well, but it's not. Too bad. I'll do a clean, just to be sure. Does it make sense to do it once more? We'll just try. Is there another question in the meantime?
Yeah, how does it affect heavier plugins like I use PyTest?
Mm-hmm.
Maybe anything being gained by PyTest. PyTest is a heavy test by itself, so it goes through all the tests and does all the mutations and stuff. Does it help there as well? It might be with a parallel, but I'm not sure.
Yeah. Would using parallel builds also help for mutation testing? Could be. But there again, there's a little caveat because it might consume so much CPU that other things happening in parallel actually suffer from it. So there again, I would say try, measure, and see if it actually improves. And if you observe that it actually bottlenecks your build because it's eating all your compute power, then it might make sense to not do it. I believe, by the way, that PyTest itself also runs all the mutations in parallel. So probably the gain is not that big there. Okay, let's see what we have right now.
There's also another solution. The new version of PyTest runs smarter, so analyzes your code and just runs the test that you're changing.
Oh, that's an interesting one. For the people in the back, newer versions of PyTest also look at the code that has actually changed and only run the mutations that cover that changed code.
That's basically the paid version of PyTest. So
you have to behind the paywall. So disclaimers here. Yeah. I can imagine, especially on larger code bases, it could make sense to consider such optimizations. Let's see once more if it behaves a bit the way we expect, and otherwise we'll just leave it. For now, yes, we're going to clean up, and now we're going to run it in parallel again. See, that's the important thing. If you start working on build optimization, you really need to be sure you have a clean test bed and you don't have the results of earlier tests that may influence how today's build runs. Fingers crossed this time. One more. Yes, please.
What is that super fast build before we actually run the regular build or the even?
You mean the one that runs in 0.3 seconds? It's cleaning the previous build output. Because otherwise I would be cheating. I would first run a build. It takes a minute. Man, that's long. Then run another build. Whoa, look at how fast that is. Yes, because all the work was already done. So that's a bit of cheating. So I make pretty sure to first clean and then run it again with Maven Daemon, and then hopefully it runs quicker. So we had the first run in 49 seconds and the second one in 38 seconds. So that shaves off an additional 10 seconds here. That sounds great, but maybe we can go even one step further. We have a daemon that is trying to run builds in parallel. Maybe we could feed that daemon with more modules to build in parallel, right? That would be great. And that brings me to a trick that might help, but really has a lot of caveats. So proceed with caution, but I'm going to share it with you anyway. And that is optimizing your application architecture for a quick build, rather than the other way around. And this really involves heavy utilization of Maven modules, not to be confused, by the way, with JPMS modules. So you may be familiar with ports and adapters. Typical application architecture could look like this, where we have ports and we have implementations for each and every port. And some of these implementations have extensions for JUnit to make testing easier. If you would study literature, you will typically see the suggestion to create Maven modules like these. One for your core, one for your adapter here, one for this adapter, one for that adapter, etc., etc., etc. Every adapter gets its own module, which also has some testing utilities, etc. And we have a few domain classes that live up there in the corner, which is great already. There's nothing wrong with this. But if we really want to leverage parallel Maven builds, we can do a lot better, and we can actually cut these modules in even smaller pieces. And we could say, for instance, okay, each of these interfaces and the classes that support them lives in their own module. Hey, we have an adapter and we have test code. We have a JUnit extension to actually make testing that code easier. Thank you. Why don't we throw them in separate modules so that they can be added to the build lifecycle earlier? If you have a lot of modules with few dependencies, this can definitely speed up your build. Because small modules compile quickly, etc. You probably won't need ArcUnit or any such tool anymore because your Maven exports already define what classes you can access and what not. And it makes it easier to exclude transient dependencies that you don't need. On the other hand, navigating your code base can be a bit harder. You need to really take care about runtime and compile time dependencies. And especially if you're a library maintainer, you might probably not want to do this. This really kind of is a trade-off, right? Because yes, you profit as an application or library maintainer. But on the other hand, what is the impact for your customer? If you tell them that they need, rather than one dependency in their class path, they need 5, because it optimizes your build. Might be kind of a strange message to your users. And for applications, on the other hand, this may impact your application architecture. It could be a balanced choice to make, but well, really, there's a trade-off here, and maybe it's not suitable in your situation. I don't have a live demo for this, but just to show you that it does not always work, Shiro, as I said, it's a library, and here we can see adding modules actually made the build run longer. So this really is one to only apply if you know it makes sense to do it, and if you are really willing to invest in it. I have one more, and it's going to be challenging because we're almost on time, which is the Maven build cache. The Maven build cache is really about optimizing the work not done, which I like. So everything that has been done before is added into a cache, and when you run a new build, it will see in the cache if there's an up-to-date result for this step of this module, and will take it out of the cache rather than do it again. As a result, only the parts of your build that have actually changed will be run in a subsequent build. It does a few tricks in terms of version normalization, so even if you run over multiple branches of your project, it will still be able to find a valid cache entry. And it will then pick the files out of that cache and act as if that was the result of, for instance, invoking the compiler plugin. So the cache extension looks at modifications to the POM, dependencies, plugins, etc., but it also looks at your source code itself. It doesn't look at a timestamp because that's not so reliable. It really takes a fingerprint of the content of your source files and then uses that to see if it needs recompilation or running the test again. There's quite a few things you need to take into consideration. The cache extension only works with Maven 3.9 or 4. You can't be doing things like, oh, I'm using the Run plugin here, or that kind of stuff, and it copies a few files over, because the cache extension assumes that you use standard Maven constructs. It makes sense for local builds. You can also use it in your pipelines, because you can actually share the cache, for instance, using Redis or other such mechanisms, with other people and even with build servers. This is a great thing. Imagine your build server running your large project and you wanting to run a build locally, and you can just borrow results from what has been done in Azure DevOps or Jenkins or whatnot. But this, again, is an optimization that really needs your time, your investment, because you need to investigate how you can make your cache portable. The Maven build cache extension, as I said, is an extension, so you add it to extensions.xml, and optionally you can configure how to compute that cache, but I'm not going to dive into that today. The documentation is pretty extensive. Let's see if we can do one more demo for this, because that is really an interesting one. Cache. The first run, I'm now using Maven Daemon because, well, that's quicker, as we already saw. Great, great, cleaning it up. I'm going to do oh, I almost forgot to say, this was the second build using the cache. Look at this, 0.42 seconds. We came from 1 minute, right? 0.42 seconds. Now I'm going to change one more file, simplecookie.java, and I'm just replacing a string constant here. Any ideas? How long will the next build run? 1 second. Okay, I'll take 1 second as a guess from the audience. Close, but a little bit pessimistic.
But the tests need to run the tests. Core instead of web.
Core is here, and web is later in the life cycle.
Yeah, but if you change something in core, then it will have to run the whole core or just one file?
It should compile only that one file, because all the other stuff is still valid. And if not, then your compilation will fail, obviously, or your test will fail. So this really looks into optimizing the work not done. And then again, and I'm repeating myself here, I know, be aware that cache invalidation is a dangerous thing. We know that from production code, it also applies to your build. Sure, I can throw everything in my cache, but that will put responsibility on me as the build engineer to actually ensure that the cache configuration is valid and it will be evicted in the right moments. I'm not taking a question at this point because I'm running a bit short on time, but you can see me afterwards and I'll be happy to discuss. So the caveats here, you need to tell this extension what your relevant inputs, build inputs are, especially if you use other input files than the standard source main Java and source main resources. You may want to add plugin parameters into the cache computation. You may want to filter out non-essential files, such as IDE configuration and such. It can happen that your tests will not run, and that may be okay, but maybe not. That's really up to you. I can't tell you upfront if that is a good idea or not, but be prepared to investigate, does it make sense, or should I force tests to run? And if you share your cache with other people, be aware that maybe the extension decides not to use it because, for instance, the remote cache is on a Linux platform and you are running on a Windows platform, or whatever kind of mismatch there can be. Also, Maven profiles can cause a cache miss. And as usual with caching, cache eviction is probably going to bite you at some point if you use this extension. But on the other hand, it can be a great way to improve your build. Finally, things that I did not cover today but may impact your build. The logging of your production code. Take a look at log, bag, log4j, or whatever you use and see if you can reduce the logging while running a test. There's an interesting showcase by Christian Stein showing how JUnit Jupyter leverages virtual threads or Project Loon from Java to achieve even greater parallelism in unit tests. And finally, and probably your sysadmin is going to hate me for this, take a look at virus and threat protection because, well, they do something with your disk in every file that you access, right? So that could probably slow down your tests. And have an open discussion with them. What is the risk versus what is the price that we are paying as a company if everybody gets slowed down by this? So I'm going to wrap up real quick. We learned today how to measure your build at first, and then that you can run parallel tests within one module, that you can use the Maven daemon to keep Maven warm and use parallel modules, that we can actually feed our Maven daemon with more modules so that it can achieve a greater parallelism in the overall build, and finally that there's a thing called the Maven build cache, which can speed up your build even more. With that, and I'm running a little bit over time, thank you so much for your patience. We've made it. That's always the thing with builds. They take longer than you expect. Sometimes also happens with presentations. If you want to play with the demos, take a picture of the QR code. You can follow Benjamin or me on whatever social media you prefer. For me, the handle is the same on all major platforms. We both blog about this stuff as well. And as a final question, if you have any remarks on this talk, I'd be happy to read them through the app or have a conversation with you in the hallway. I'd love to hear your thoughts on this. Enjoy the remainder of JSpring and have a great day. Thank you.